Welcome everybody to today's vOLTHA TST meeting for the 6th of October. Thanks for joining, and as usual, the call is public and recorded and will be published on YouTube. So please be mindful of whatever you share during the call. First of all, I want to take a little bit of time to make sure that everybody had a look at the 2.6 roadmap, and to ask if there are any questions about it that were, this was discussed last week, but I wanted to take the opportunity to understand if there are any questions, any thoughts that were had during the week that last time were not addressed. Okay, seems not. So I guess that's the 2.6 roadmap. We'll keep it updated. We already have, like, for example, the BBSIM implementation that is being done by Amit, updated it there. So we'll keep it up and updated. So please do refer at this document for the 2.6 December, end of December release. Second topic that I wanted to tackle today, before the big one that is the software upgrade, is the fact that as an update, we have a successful run on DT workflow of the OpenONU Go adapter on hardware. This is really great news, because one of the targets of 2.6 is actually putting in the adapter as the default, the Go version instead of the Python version. We discussed it last time, but this was it's a good successful run we got this morning, and pretty happy about it. And it's a test that you guys can see. It's here. It just runs the sanity test. So if you look at the robot results, it's just basic startup and ping, but that's a very good, I think, achievement. I also know that Girish tested it. This test is with Circom and the GPON OLT. I know that Girish also tested it with Alpha and the XGS PON in Menlo, even though it's not automated yet. And that also passed, so that's also very good news. Before I go forward, any questions on this?
That is great news, and it's an early day, so I'll ask the question, not expecting an answer yet. Any feel for the performance difference?
Actually, yes. So if we go to Jenkins, we actually do have a scale job that is running at the moment with the DT workflow. And this one has a 1 adapter, ONU Go adapter, the same scale that we're targeting with the 8, that Python version. It's the 2 OLTs, 16 PON ports, 32 ONUs per PON port, so 512 ONUs each OLT. And except this failure that I have to look into, there's very, very good timing. In about 3 minutes, you can actually take a look at the plots that Theo prints. And you can see that except the failures, just discard those. We need to investigate. It might be infrastructure related, but the ones that do actually pass, you can see very like 122 minutes to get to the check of the flows for 512 subscribers after subscriber provisioning. So it's very fast with just 1 instance.
Excellent. Yeah, do you know the numbers offhand for when it was run with the Pi version, multiple instances?
For just 1, we don't have them because we cannot reach the 2 LTs, 500 ONUs each.
No, for DT, yes, Andrea, we have it.
Yes, but now, not with 1 adapter. We have it with 8.
No. With 8 adapters, it takes about 190 seconds. So the main difference is in the time that the adapter takes to go through the OMCI process. That's where we get the main benefit. Then the flow processing and all the other stuff is pretty similar performance, because there are many more components involved in there.
Yep.
Cool. Thanks.
No problem. Any other questions on this?
I think we should also check the CPU usage. So the Python version, 8 instances of for a new adapter uses at most 8 cores in total. So we should see the same on the Go version.
Theo, is that something we collect in this job, or is it something that we have to add?
We are collecting, if you go in the logs, we are collecting some information about CPU and memory usage. I'm not entirely sure it's currently working, but I can dig up, there is a PDF and a CSV. I can dig up the numbers and share them on the mailing list.
Okay, thanks, Theo.
We use MIP templating, right?
Yeah, in
Not.
Scale, we are always using MIP templates.
Yeah, okay, thanks.
The one thing that the OpenONU adapter Go does that the Python does not is actually that even if we did not use MIP templating, it actually learns the MIP template from the first ONU and populates its etcd with it, and then it reuses that MIP template for following ONUs.
Yeah, that's good actually.
Yeah, that will make quite a big difference in the field. It won't make a big difference in the scale test because all the news are coming up pretty much at the same time.
Yes, and also I don't know if we expect to use it actually in the field. It's a very good feature to have because if some new ONU gets connected, it gets learned. But my idea, at least our idea that we discussed also with Theo and others, was that this could be used at development time and field testing, and the template be grabbed at that time from an actual physical ONU and not having to be constructed and then just populated into the field in the field deployments in etcd.
Yeah, most of all, I don't see a new ONU going into the field before going through a trial, and that's a very good tool to capture the MIP template.
Precisely. Okay. Any other questions? Okay, if there is nothing more to add on this topic, I'll let David take the reign of the meeting to present the great work he has done in the document that we shared last time about the software updates and what are the next steps and needs for getting this into the vOLTHA system.
That's quite a buildup. Let me grab the share and just so I can walk through. All right, I'll walk through this document real quick. Please interrupt when you have questions. There have been a lot of threads and comments on the document itself. I leave those comments open, mostly because they contain information, well, mostly because the person who started the comment thread haven't resolved it if they felt it's resolved, so I just left them open. So please follow those threads too if you're interested in a particular area. They do carry some good information. The general direction of this proposal, if you will, for software updates is use the tools that are available in Kubernetes to update the pods and live with what they have. Don't try to do anything special around it. To just use the tools that exist. In particular, use the rolling upgrade capability of Kubernetes. That capability can be engaged or initiated either by using Helm upgrade commands or kubectl commands to set specific or make specific changes to manifests. A rolling upgrade policy within Kubernetes basically says, look, I see a change in the manifest. I'm going to kill an existing pod and restart it. You can parameterize that so that if you have multiple pods supporting a service, which for most things in vOLTHA we don't, You can say, I need at least this number of pods always running and ready. And therefore you can kind of, again, stage the upgrade, if you will, roll it through, and always have the service active during the upgrade. It is important to note that during a rolling upgrade, what you will see is if I have 2 versions of the pod, I'm upgrading from version 1 to version 2, and I have 3 instances of that pod running, there will be points in time where I'll have both version 1 and version 2 of those pods executing simultaneously, and being routed from the service, Kubernetes service, to those pods. So that's just something to be aware in the scenario where you have multiple pods backing a service and you're doing a rolling upgrade. As long as we're API compatible, shouldn't be an issue, but it is something to be aware of as we go forward and develop. What I found out in terms of our test dev environment, vOLTHA, it uses port forward command in kubectl to expose services in a cluster to your local system so that we can do testing, play with it, whatever. Those port forward commands tend to fail when you have a single service backed by a single pod, and then you restart that pod. It's a known issue with port forward, and to be fair, in a production environment, we shouldn't be using port forward. We should be using an ingress controller to manipulate this better, manage this better. So just something to be aware of. I talked a little bit about API compatibility, like a half a sentence. When you're doing a rolling upgrade, there is an assumption that from the old pod instance, old version to the new instance, there's API compatibility. If there's not, things will break, or any incoming calls in the interim may break. For instance, if I'm doing an upgrade and I use the version 1 API and it's not compatible with version 2 pod, things will break. Reverse happens as well. If there is a compatibility change or API compatibility change, my recommendation really is, hey, it's time for a maintenance window. Let's do a clean shutdown. Let's bring everything back up and get things working that way. I can't remember if I think it's discussions later on. I'll bring that up. The other components, or one of the components in vOLTHA, is ONOS. ONOS is kind of developed independently. It has 2 basic containers that it uses. One is the controller and one is storage. The storage container, Atomics, must always have a quorum. If Atomics breaks quorum, bad things happen. So when you're doing a rolling upgrade and you've got Atomics that you're dealing with, we need to be careful of maintaining that quorum. And again, that can be controlled by the rolling upgrade parameters. The controller aspect of it doesn't require a quorum, and so it can be upgraded using standard rolling upgrade path practices that should work. I did want to note here that just a real quick test when I did this, and this was many months ago when I started this document, there were some Atomics issues with rolling upgrades around Atomics and ONOS. Just a note in the document there so that we need to test it. In terms of vOLTHA upgrades, etcd and Kafka are somewhat out of the scope. They should work with just standard rolling upgrades. They are both components that we don't develop. So, there's, again, unless we start contributing upstream changes to help rolling upgrades, I don't see much we're going to do here. Again, just be careful and note, when I was doing some preliminary testing, I saw some failures when I was using etcd with persistence. And I did a rolling upgrade of etcd and then restarted, or I think restarted a pod in vOLTHA, and things just did not reconnect correct. There's bad data essentially. So again, this is just a call out. There does need to be some significant effort around testing for the rolling upgrades, and being able to, in that testing, do upgrades of various different components, and that just to see how the system reacts so that we get those edge cases. vOLTHA itself does not do standard high availability, or what I mean by that is we don't typically have a single service with multiple pods backing it, or any other HA implementation. It's kind of a fast failover mentality. So what we'll see on these components, the core, the OpenFlow agent, and the adapters is when they are rolled or when they are upgraded, any commands that are meant to go to them may be disrupted, may fail. So that's something to be aware of. There's discussion on the side about, do we need to put the system in a upgrade state while we do this to prevent someone coming in with a vOLTHA command, trying to issue a command, so that the system itself knows how to react, or at least is aware that the system's an upgrade and can make an intelligent decision about that. There's a couple different thoughts on that subject. The question is, well, in Kubernetes, if I have a service and there's no pods backing that service, what happens? And I think, again, using my memory here, not a recent test, that can actually lead to a timeout, a hang, as opposed to an instant failure. So there is a thought, do we want to have kind of, I'll call it a placeholder pod that I can put in place in some of these components so that when I'm doing an upgrade, I map the service to this placeholder pod, and this placeholder pod really just returns a, hey, I'm upgrading error message, so that, pardon me, the callers of the system understand what's going on and can react accordingly. Getting some things to play with, I think some things to prototype to see which works best for us in this scenario. And again, that would be mapping a service to this placeholder. Then once we upgrade the pods, map the service back. Where we're going through services, that might work. Again, something to experiment with and see if that works better. The other thing, just about services, when I have a service backed by a pod and that pod's in the not ready state, Kubernetes should not forward request to the pod. So again, if we can force a pod into a not ready state, Kubernetes won't route to it. But again, we might also then get API call hangs or timeouts as opposed to failures. Any questions really at this part? I mean, it really is saying, let's just use standard best practices in Kubernetes, but any questions so far?
I couldn't follow the etcd problem, David.
Okay, let's back up to etcd then. The etcd problem I saw, is that the one the one the notes about, you mean, or?
No. I think there's no problem with the etcd, but there's a problem with the vOLTHA components connected to the etcd when the upgrades happen. Is that right?
Correct. etcd does upgrade or do a rolling upgrade fine. That's not a problem. The data remains in the persistent store. That seemed to work. But vOLTHA was no longer working after that.
It's interesting.
Yeah, and again, it needs to be retested. I did some simple testing. I thought it was odd too, but it's something to test. That makes sense?
You don't have any logs, right?
Yeah.
I'm sorry?
Do we have any logs?
No. This was me hacking away while I was doing the document. And at the end of this document, I talk about it. One of the big efforts around this is going to be test, automating, defining those tests, automating those tests, and then we'll have those logs.
Oh, okay.
Any other questions so far? All right. The OpenVOLTHA agent, i.e. the bit of software that's on the box itself, the recommendation, I know there's already some work through the device adapter interface, or not device adapter, but the device management interface to deal with the upgrades there. And that's all I'm really saying here is, look, there are ways to deal with software upgrades for components on the device. Those devices, each vendor has perhaps their own what mechanism to do it. Leverage that. Don't try to do something smart about that. Just use that. And then finally, it is, again, test and verification. I found several failures during my test. Some of them were issues that need to be looked at, retest. Some of those are, oh, this behavior, I guess, makes sense when I think about it, but it may not be the behavior that I really wanted to see. And So one of the follow-ons to this will be defining all those tests and then implementing them. That really is a document. Again, the summary is leverage the rolling upgrade of Kubernetes, and where we need to tweak things, let's see what that is and try not to tweak anything to make it non-standard. The biggest issue seems to be about requests that are in flight during a rolling upgrade may cause failures. And do we want to mitigate that by either documenting a process for upgrade or leveraging what I call placeholder components or some other mechanism so that you can put the system in some sort of I'm upgrading state, such that you essentially drain all existing requests, go into an upgrade state, and then reject new requests until upgrade's finished. And those are things that need to be thought about a little bit more. That's all I had, unless there's questions.
One question. So when we have multiple vOLTHA stacks, would it be possible to upgrade only one instance of a pod, or do we have to upgrade all of the instances in all vOLTHA stacks?
You can upgrade individual pods. You can upgrade a single stack. I would recommend, in terms of best practices, that you do a single stack as the minimum unit. But no, you don't have to upgrade the whole entire system at one shot.
Okay, great. Thank you.
So is your only open question the case, I mean, modulo finding issues when we actually start trying this thing out? But your only open design question is whether we need to go into some kind of standby mode to respond to API calls.
Yeah, that really is kind of the big open question. Or do we just say, look, here's the best practice, drain requests, take into steady state around us, right? You can do a rolling upgrade in a maintenance window, therefore don't expect new requests.
But it's not just API requests from vOLTHA, right? It's also API requests going to ONOS.
Any control plane request, yeah.
And also, alarms from, bottom, from the device. So.
Yeah, events from the device, right?
Yeah.
I would think, this is a good approach to start with. But, we need to think more on that.
Yeah, I mean, even if we put things in a I'm upgrading state, if you will, any event coming from the device would get the message, hey, the system's upgrading, or the pod I'm trying to communicate with is upgrading. And then, if the agent's coming, if the event's coming from the agent, it would have to decide what to do with that event, whether to drop it, store it temporarily, and then push it when it reconnects. The benefit of having the kind of system be able to report that it's in an upgrading state is, of course, components can react to that and make intelligent decisions. The rolling upgrade policy, if we don't do that, vOLTHA is a fast fail. So the processing of all events or all API requests would be similar to the case of, hey, a component crashed and restarted. So even if we didn't implement the I'm in an upgrade state, we're going to have to deal with that same issue of what happens if for a request in flight when a component crashes? What happens to an event from the device when the adapter crashes? Similar issue. So, I mean, that says the simplest thing is not to do anything and just handle it the same way.
As long as the data plane is not affected.
Correct. And that has been one of the driving design points, right? The control plane should be able to crash, but The data plane traffic should continue to exist except for that traffic which deals with like IGMP or DHCP or radius, those things that are proxied through the system.
Yeah.
Okay, so what I'm hearing is that basically try the simplest approach first, expect things will be retried, and let's see how far we go with it.
Yeah, definitely.
Anybody has any other thoughts, comments?
Well, I think that really the next step is to try every one of the services out, and whatever comes up as a bug, as a request for implementation, just create the stories for it, and then we're gonna get it done. I guess that's the way I would proceed. Create the steps, and if it passes, it passes, and we're good to go in some sense. If it doesn't, we know the steps, and we put them together in a Jira, and somebody takes it up, tries to reproduce it, and fixes the issue that come up.
So right, so there's two aspects there. One of those, hey, I've got a system in steady state. I'm just going to upgrade the pods. And when it comes back, can I then essentially run the sanity test again and have it pass? That's kind of the steady state test. And that is the bare minimum. The second is, hey, do we want to test I'm going to start a new device or start the sanity test and do a rolling upgrade in the middle of the sanity test and see what happens. Right.
So my preference, but I'd like to hear everybody's opinion here, is to do the first one.
Yep.
Especially given that one already might prove some challenges, and that is okay. We if that is done and achieved and passing, we could say that we have a system in place that, given a maintenance window where no requests come and no process is happening, we actually do have a procedure for updating the software. After that is done, we can then look at possibly doing in the middle upgrades. Does that make sense?
Yeah, that makes sense in terms of how to process this or go through kind of the steps. And to the point earlier, I think it was by Garesh, even doing a rolling upgrade, synthesizing events from the OLT agent at some point, just to make sure how the OLT agent, those are other tests. So it's going to come down to is how thoroughly or how many cases do we want around this. And that'll be a factor of time and resources as well.
I think this needs to be documented a little more on how we want to do this. So how do we deal with failures during in-service upgrade?
What do you mean, how with dealing with failures during service upgrade?
So when you're in service and when you do the upgrade, say any calls, vOLTHA calls from the northbound or any events from the southbound, they are not events from the southbound are not propagated upwards, and vOLTHA calls fail. So how do we deal with that?
To the point earlier, it's going to be the same scenario as if I make a vOLTHA call and the core crashes, or I have an event coming from the device and any component crashes. Right? It's the same pattern. Essentially, all Kubernetes is doing is killing the pod, right? It's a directed crash, if you will.
Yes, but these cases are, even today, these are not tested. I mean, we do have restart tests, but we don't invoke any calls on the stack while we restart the pod. So these scenarios are not tested well enough, or in fact not tested.
So what Girish is saying is that basically even in the restart containers test cases that we have, we're doing steady state
Yes,
what you
I
would call
agree.
steady state, David, steady state based tests.
Yep, I agree.
We're not doing the in-flight based tests.
I agree.
So my point is we need to document the system behavior for such scenarios because we have none at this moment.
We also should have a pod running or a vOLTHA instance running where we're doing running Chaos Monkey on it, so that we're just continually running tests, and every now and then something just crashes. Right? If we're going to be honest and want to get a real hardening of this, that's what we need to do.
That's why I was suggesting the first step, the steady state first, because that's what we already do, as Girish pointed out. So I think that's a pretty good start and a pretty good stepstone. And then the Chaos Monkey might come in for this, but also for pod restarts, just without upgrade. Just plain.
Again, an upgrade's just a pod restart for the most part.
Yes, it's then we might want to start with restarting an existing pod and then moving to upgrading one.
Yeah.
But I guess the two steps is the important part.
Yeah. The only other point that I want to bring up, and I just thought of this, even though it's in the document earlier, or at least the side comments, is we talked about API changes or API incompatibility changes. There's also the what do we do in terms of when the data between versions changes. I'm updating the core, and there are 12 new data fields to some record in the KV store. And so there's a data migration issue. The recommendation in the document or comments or wherever it's put here is also, hey, when there is that type of incompatibility change around data, it's, again, maintenance window time, bring down the system, migrate the data, and then bring up the system, as opposed to try to do a live migration, i.e. when you get the new data, when you read a record, update it, and kind of build that data migration into the code. And the recommendation is that simply to keep the concerns separated, and also trying to implement a live migration in the code complicates the code itself and makes it harder to support.
Okay, so that was my comment, but like embedding the migration in the code is not what I meant with that comment. What I meant was like drawing on my experience with principally web frameworks. Most of them come with a migration engine. And so anytime you deploy a new version of your code, the first thing that happens when the software starts is, let's check if I run all the migration that I have. If not, before starting, I'll run the migration. So that's a separate concern, but it's kind of embedded in the software, but it's not within the code path of any request to address the migration. It's when I start up, is my data structure up to date with my code, or do I need to run some migrations?
Yeah. I guess I just worry about in this environment automatically doing any of those data migrations, even on pod start, if you will. As an operator, my gut feel would be I really want to know what's going on in my system. If system's doing upgrades automatically, that I can't either say, yeah, go ahead, or no, don't go ahead. It's problematic, and it also means that, hey, what happens if it starts an automatic upgrade, fails in the middle, and can't back out? How do I recover? Just keeping the concerns completely separate. Again, that's kind of my opinion. If others, and particularly if the operators see it differently, I care. I just see it as kind of having a formal process. Also, that means I can have my data migration where I can say, look, I'm going to upgrade from version 1 to version 2. And I have an upgrade for that. I can also have an upgrade from version 1 to version 3, as opposed to, always kind of building this into the startup code, even if it's calling a separate procedure to do so. I would be curious what DT and TT prefer in terms of data migration when there are incompatibility changes.
Based on the last comment, I'm just wondering, is this document more about software updates that is self-contained in the container where there's no API changes and no data changes?
Yeah, it basically is about that, saying, hey, use rolling upgrade. When there's incompatibility changes, we can still use rolling upgrade, but the recommendation is at least do it in a maintenance window.
Oh, okay.
And then for data incompatibility changes, it might be, hey, maintenance window, shut things down, upgrade, restart.
I'm not following what Matteo was trying to say. Is he opposed to the procedure that is outlined so far, or Matteo,
No,
yeah.
I'm not opposed. I'm fine to have a completely separate tool to run the migration. I think we'll just need to figure out how to build some protection into the code, meaning like I create my maintenance window, I upgrade my software, but for some reason I didn't run the migration. Then what happens?
That's a good point. That's an excellent point, right? There needs to be kind of a schema version so that when a component starts, it can check the schema version it's operating against, if it's writing to the KV store, for example. And if there's a schema mismatch, it can crash with an appropriate error or panic with an appropriate error. I think Matteo is referencing there are systems out there that basically check the schema version on start. If the schema version is not what it wants and it has a capability into it, it then upgrades the schema and then continues on its merry way. And if you have a single application, that can work quite well. I think when there's multiple components, there becomes an issue of who upgrades the schema. What happens if I've upgraded one component that upgrades the schema, but the other components aren't ready for that new schema?
Well, if you have two components accessing the same schema, I think you're missing on your separation of concern. But each component should be responsible of its own schema.
Where that doesn't happen is if I have two pods that are backing the same service and they're both writing, you know what I mean? Essentially, back to the old read-write core where we had that scenario. In the current form, we probably don't have it, but in the old form, we did.
Yeah, that's more of an HA concern. And I think if you have HA and you can have multiple versions of the same service running at the same time, then simply you cannot do breaking changes in your schema.
We may have we do have a capability of running multiple cores at the same time during a rolling upgrade. Just because the old core and the new core may overlap in terms of their existence, although only one should be ready at a time. So only one will be accepting requests, but both could be actively running.
Well, but I thought we were talking about maintenance windows. So during the migration period, no one will actually read or write to the store.
Yeah, correct. In a maintenance, that's part of the reason. That's part of the reason to recommend the maintenance window. Just control it.
Yeah, I guess having a maintenance windows will make our life much easier because we don't have to bother with all these details about schema and compatibility, because we can completely change the structure of the key value store because we know then when we're back online, only the newer components will be
reading or writing into the store.
And it also facilitates a process where the operator says, "Hey, I want to back up things, then migrate my data, then upgrade, then start the new version. And if there's a failure, I have a path back to the previous version."
Okay, now I'm confused. Are you recommending maintenance window all the time?
No, for schema changes.
Just the schema change. Okay.
Yeah. Actually, I think the document says schema change and API compatibility.
API compatibility. Yeah. Okay.
Which is really a schema change from my perspective.
So the kind of things, Matteo, we did in XOS last year, are you referring to those things where that the components themselves are checking for versions and doing migration?
Yeah, that's correct. That's the other approach. That's more the CI/CD approach, but it was slightly a different situation. That will get you to go through the changes without having a maintenance window. And you can migrate the data as long as you always have backward compatible changes. In the vOLTHA case, given that even tearing down vOLTHA will not disrupt the main functionality that is getting users out to the internet, I think it would be an easier approach for us to have the maintenance windows, unless there is a concern from the operator that we need to be able to make changes at any given time in life. But I don't see why that would be the case.
And again, for like bug fixes and those things that are not changing the schema, maintenance window isn't required. It's only for those kind of breaking changes, if you will.
Okay, thanks.
Yeah, in our case, a schema, the way we store the data is really in proto.
Yep.
Proto change. So pretty much any proto changes will require it's equivalent to a schema change.
Yeah, that is an issue, but yeah. Which says to me, honestly, that, hey, minor changes for vOLTHA, bug fixes and minor changes, those can be done via rolling upgrade without a maintenance window. But a change from version 1 to version 2 to version 3, major changes will likely, where the protos have changed, will likely require a maintenance window.
How do you envision ONOS app changes that?
Good point.
Maybe it's already in there, but it's not a wholesale change of ONOS, but just an app. Let's say I found a bug in an app and I can fix that bug without, say, changing how the app stores data in Atomics, let's say.
Yeah. I didn't really cover ONOS changes other than kind of there's ONOS and there's Atomics. If we're looking to upgrade an app, I'm trying to understand. I don't know if you can dynamically load a new version of app into ONOS or not, and it will just start taking over. I'm thinking you're going to have to restart the. Go ahead.
There is an app activate tool where it basically goes in and wipes out the old app and installs the new one. You can do that dynamically.
Yeah, the issue with doing that, it might be that we wipe out the data in Atomics too, because usually what we do is that once the app is deactivated, we purge the distributed map state. And we do have some distributed map state within our apps. So we might need to take a look at that and possibly having some options, I guess, to do that or not.
Yeah.
Okay. Maybe we should make a note of that in that document.
Yep. I don't know if someone's taking notes from the meeting or not, but if not, I can go back over the recording and look at that. Or I can just do it right now.
Okay, so as a next steps exercise, David, would you mind creating a set of Jira stories for
Okay.
the first set of tasks we think we should
Okay.
attempt?
I can do that.
Yeah.
I can do that.
Quick question: do we have any idea on what the testing with will look like? Meaning, like, do we anticipate something like we deployed the last suitable stable version? At the moment is 2.5, and then we try to upgrade to master, and we make sure everything still works. Is that?
Well, that might not work because 2.5 has nothing in place that might be needed for this. Let's say we do purge some state upon deletion of the service. We might need to actually not do that. And I wouldn't go back and port the stuff to 2.5. So maybe if that is the case, we could do like a previous version of master or something like that, like 2 or 3
all you really have to do is create a new different tagged image, right, to do this. So I can create 2 images of master, one tagged foo, one tagged bar, and upgrade foo to bar. And,
yep.
and
If foo and bar are exactly the same, then we are not really upgrading. We are restarting a pod.
Right, we're restarting a pod is what that really tests. The only time that we would, if you're really, we do eventually want to get to the point where we're saying, hey, I'm upgrading from 2.5.0 to 2.5.2 in the test, right? Where there's no compatibility issues. Well, and we're just essentially doing a pod restart.
Well, the thing is that even within the master code base, there are different versions of each service. So we might look at just going from the master version of OpenOLT adapter to from a previous version of the OpenOLT adapter, even within the same release, to the master version. Like start a system with the 2.6.2, I have no idea what the version is right now, and update it to master.
Well, tags are cheap, right? I mean, why can't we just, sort of create tags specifically to test these things out, right?
We can, and we can also just keep a running pod, and every night upgrade to the latest master too.
Yeah, why not?
Yeah, that probably is something that once we feel like we're ready, we should integrate with the soak pod.
Yeah.
Indeed. But in any case, I think that for the initial steps that we are going to take and the outline, the set of steps that we described before on how to do it and how to reproduce it from a stable state system, I think that going from an older 0.01 version to master is good enough. Right?
Try that again, please.
I was saying that for the initial set of tests and set of manual steps to make sure that this works, going from a minor .1 version to master works.
Yeah, it does. And again, that is not going to test anything significantly different than a pod restart is what we're going to see there. But yeah, we can do that. I do think in terms of testing, there's a huge overlap between this and just normal pod restart.
Okay. Any other questions or comments?
To be on the same page before opening the tasks, I think the consensus is on using rolling upgrades for minor changes and bug fixes. And for the major changes, we will go and shut down the process and totally upgrade it. And the task will be opened accordingly. Is that correct?
Yeah. The caveat there would be, even in the maintenance window, it doesn't necessarily mean you shut everything down. You could still accomplish that with a rolling upgrade in a maintenance window. But it may be that it is safer to kind of do a cold restart.
Okay.
I would go ahead and add one more thing. We need to define the behavior when doing rolling upgrades. And you have events coming from the devices, and you have invocations from the northbound, API invocations from the northbound.
And also, do we have a consensus on the data migration? I think we don't have right now. Should we have some POCs, define some POC tasks? In terms of multiple OLTs, probably I would like to upgrade one vOLTHA stack first, and if it needs a data migration, probably I would want to migrate the data in etcd for that instance. But also I should have a procedure to roll back if something goes wrong. So there might be multiple ways doing that. For example, I can bring up a new instance of an etcd cluster and migrate to data in that instance. Or I don't know. We can change the actual data, and maybe we can find a way to roll back that data. I think we should have some POCs around that issue.
Yeah. Also, we need to make sure that if we're going to upgrade a single stack, that the data associated with that stack is only touched by the components in that stack, right? This means that certain branches of the etcd tree may have a different schema version than others, right? Because if I update stack 1, all its data should be, schema version 2, where stack 2 might still have the original schema. And so if we're doing any kind of cross reads, that's going to become a problem. I don't think we are, but it's just something to be aware of.
Yeah, I agree.
Okay. Also, in the interest of time, I think we have reached a pretty good consensus. So David, I guess you're gonna go ahead and create the Jira stories whenever you can, and then we're gonna take turns at fixing them, I guess.
Yep, I'll try to update this document a little bit as well.
Thanks a lot for that. I'll publish.
Did you make a note of the rollback part and the ONOS apps part?
The ONOS apps was done before, yes. I think it was up there. The rollback.
Okay. Yeah.
And David, do you need any feedback from the operators?
I would love to understand their preferences in terms of upgrade policies.
Do we need a note on that too?
Okay. Then I'd say that thanks, David, for the great work that you have done with the document and for the Jira stories that you're going to create. If anybody has any other comments or thoughts on this, please do feel free to put it in the document or on Slack to myself, David, whoever was on the call, or in any of the general channels. That's pretty good. Unless there are any other comments, given the fact that we are basically on the top of the hour, I would say that we can meet again next week, and I'll send out a reminder email as usual for the topics. Any last questions before we finish up? No? Okay, then thanks everybody, and let's continue the great work as usual on Slack and the email. See you next time. Cheers. Bye-bye.
Thank you. Bye.
Thanks. Bye.
Bye bye.